guys, so I'm going to talk to you a little bit about scientific notation, but it's going to make a lot more sense if I review some stuff about exponents that you've learned in math first. So first I'm going to do a little exponent review, and this is hopefully stuff that you've seen before, but if not, that's okay. And then after that, I will actually dive into some scientific notation stuff. So thinking about exponents, exponents are just repeated multiplication. So if I have 10 to the third, that's the same as saying 10 times 10 times 10. And if I have a negative exponent, that's the same as repeated division. So this would be 1 over 10 times 1 over 10 times 1 over 10, because this is some number could be here, right? Dividing by 10 every time. So this is repeated division, and division is just fractions. So repeated multiplication or repeated addition is what we're looking at when we have exponents. If we have, I also want to talk a little bit about operations within exponents that you, again, hopefully have seen before. If I have multiplication of two exponents, for example, if I have 5 to the second times 3, why did I make that a different number, times 5 to the third, that's the same as saying, well, this is going to be 5 times 5, and this is going to be 1, 2, 3 more, and then you see, well, really all we did is we did the multiplication repeated twice here and then 3 times here, so I'm just repeating that multiplication 5 times. So what I can do is I can just add up these coefficients to get the same thing, and both ways I get 1, 2, 3, 4, 5 multiplications of the number 5. If I was to do division, I had 5 to the 5th over 5 to the 2nd, then I would have 5 times 5 times 5 times 5, 1, 2, 3, 4 times 5, I would have like this. And I know that then I can cancel out one here and another one here. And I'm going to be left with only the ones on top. So then I'll have 5 to the third. And really, again, I can look at it and say, well, really all I did is a little bit of a subtraction to get that same value. Okay, so hopefully that all felt at least a little bit familiar, even if it's been a while since you've thought about it. And we're going to use all of that while we talk about scientific notation. So I'm going to delete these guys. So if we think about kind of the stuff that we do in science, we'll often end up with really, really big numbers and really, really small numbers. So if we're talking about, for example, the size of a planet, we're going to end up with a really huge number. Whereas if we're talking about the mass of an atom, we might end up with a really, 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 really small number. And so we don't want to have to write these zeros out every single time. And so what we can realize is, well, this is actually the same thing as if I was to take this number and just multiply it by 10 a bunch of times, because this is the same as saying 513 times 10 times 10 times 10. Let's see, how many times would I have to multiply? 1, 2, 3, 4, 5, 6. There. Right, so I can kind of start to see where I'm going with this. So what scientists do is they take whatever number they're working with and they reduce it down to having only one digit before the decimal. So let's start getting into a real example. So let's start with this number. I'm going to start with something a little bit smaller so that it feels a bit more intuitive. I'm going to start with 310.2. I know that to get to close to 300, I'm just multiplying 3 times 100. So this number is the same as 3.102 times 100. So another way to say 100 is 10 times 10. So this is really the same as this number. And another way that I can get to this, something that looks like this, is by counting where my decimal is and how far it needs to go. So I can look at this number and say, okay, well, really, if I want just one number in front of my decimal, I'm going to end up with 3.102. I know that's what I want. That's always how I want my scientific notation numbers to look. I always want one digit in front of my decimal. So how many times do I have to multiply this value by 10 to make it look like this? So I'm going to take this and I'm going to count how many times I have to multiply by 10 to get it to there. And I have to move it over 1, 2 spaces, or I have to multiply it by 10 2 times. And that's how I'm going to figure out what my scientific notation looks like. Let's look at another one. Let's say I have 74,000. So I know I'm going to want it to look like this because I only want one digit in front of the decimal. And I could add all these zeros, but those are just placeholder zeros. And when it's behind a decimal, it's not going to change the value. So this is just going to make it look uglier and say the same thing as this. So I'm just going to leave it like that. All right, and then I'm going to count. Well, on this number, I don't have a decimal showing, but I know that it's here because 0.0 changes nothing. So my decimal is here, and then I'm going to count how many places do I have to move it over, how many times do I have to multiply this by 10 to make it look like that. So 1, 2, 3, 4. So this is the same as this. Now, we also mentioned really small numbers. Just kind of want to separate these. So we also mentioned we could use really small numbers here. So what if we think about the other direction? Let's look at a really small number. Okay, now I want only one digit in front of my decimal. So that means I want my decimal to get to here. So I want this to look like 3.457. Now, instead of multiplying by 10 a bunch of times, if I took this number and I divided it by 10, it would be here. It would be 0.3457. If I divided it by 10 again, it would be here. If I divided it by 10 again, it would be here, and so on. And so we're going to use that and count, but we're going the opposite direction, and this time we're doing repeated division instead of repeated multiplication. Oh man, I can't erase my line. There we go. Okay, so now we're going to count and we're just going to go in the other direction, and then we're going to say since we're dividing instead of multiplying, we're going to use a negative exponent. So if I want to get from here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to have to divide this value by 10 times. Okay, I'm going to do one more and then we'll start talking about operations. Let's try and go the other direction. Let's try and turn this number into regular notation, not scientific notation. So this negative tells me I'm making a smaller number. I'm dividing. I'm not multiplying, I'm dividing. So I'm going to use this number, and if I'm dividing, I'm going to be making a smaller number, which means I'm going this direction. If this was positive, I would be making a bigger number, so I would be moving in this direction. I want to make that arrow blue. So because this is negative, we're going this way. And I'm going to go over that way 3 times. So I'm going to go 1, 2, 3. And this is where my decimal is, which means I have 0, 0. So I could write this as 0.00175. More traditionally, we're going to see this as 0.00175. Same thing. And then if this instead was a positive number, let's just look at that too. 1.75 times 10 to the third, and I wanted to make that into traditional standard notation. instead of moving this way, I'm going to be moving that way. So now we're moving this direction. And I'm going to do it 3 times. 1, 2, and 3. There's nobody here, so that's going to be my 0. Whoops. So I'm going to have 1, 7, 5, 0. And then my decimal is here, but we don't include that 0.0 because it's redundant. So we'll just write that. All right, let's do some operations. So now this is where that review of exponent rules is going to be really helpful. So let's talk about multiplying and dividing numbers using scientific notation. So the first example I'm going to look at is 7.5 times 10 to the 5th times, remember your dot notation, this just means times. This x and this dot mean the same thing, but I'll keep them a little more consistent. I'll use both the x symbol. Times 5 times 10 to the negative 1. Okay, so I could write this out. I'm going to expand this. Now, you don't have to expand this every time. I'm just going to do it a couple times so that you get the idea, so that it feels more intuitive to you. And then once you learn the rule, you can just use the rule. But I'm going to show it to you the long way first, just so you can get the hang of it. So if I expand, let's color code this. So if I expand this out, this is the same as saying 7.5 times 10 times 10 times 10 times 10 times 10. Is that 5? 1, 2, 3, 4, 5. All I did is expand my exponent notation. Okay, and then if I expand, I'm going to do my times, because that's what's happening between my two numbers. I'll make this one orange. And this is 5 times, now we remember, since this is negative, this is 1/10. This is dividing by 10, not multiplying by 10. So this is going to be, I'm going to write this as 1/10. Okay, so I'm going to take these numbers and multiply them. Oh, I don't know why I made this 7.5. This should just be 7. I made it more confusing than I needed to. I need my line. Oh. Ah. Okay, losing it. If I had video editing skills, this is the part I would edit out, but I don't, so you'll see it. Okay, so 7 times 10 times 10 times 10 times 10 times 10 times 5 times 1/10. Okay, this is going to be the same as, I'm going to pull, I know I can do multiplication in any order, so I'm going to pull these numbers out because they're a little easier to think of on their own. And then I'm going to think about, well, I've got 5 of these and this one divided by 10, so I'm just going to write it as, oops, I meant to make this a 5. So then I have times 10 times 10 times 10 times 10, and you see why we don't always want to do this out every time. It gets really boring to do. And then this is, I'm going to write it as divided by 10 this time. Divided by 10 and times 1/10, these are the same thing. Fractions and division are the same thing. I know that's not always intuitive for people, but once you get that in your head, all of your math classes will be easier. Fractions and division are the same thing. Dividing by 10 is the same as multiplying by 1/10. Okay, and so then I know that times 10 and divided by 10 are opposite operations, and they will cancel each other out. So I'm left with 1, 2, 3, 4. So this is going to be 35 times 10 to the 4th. Now, I know we said we always only want one digit in front of my decimal. Here I've got 2 digits in front of my decimal, so I'm going to do one more thing. Now, how do I figure out what number this is? Well, I'm moving it this direction. So I'm going to make this, now I have to think. I moved it this direction. Let's look at our previous notes. So when we're moving it that direction, we want to make our number, now I've confused myself, positive. Because it's going to take one extra, there we go, it's going to take one extra multiplication by 10 to get from 3.5 to 35. So we're going to add, make it a positive exponent when we're moving to the left, because we're going to need to multiply by 10 one more time. All right, So now I have my final answer. And let's figure out what the rule was here, just thinking about this one. So all we're doing is we're doing the multiplication of the numbers, and then we're adding up the exponents, because 5 plus negative 1 is going to give me 4. So that gives me my rule for multiplying in scientific notation is multiply the numbers and add the exponents. Then when we do that, we have to simplify our scientific notation so that we only have one digit in front of the decimal. All right, let's do another example with division this time. Totally change colors, but it's not confusing to look at. All right, so for my next example, we're going to have, let's say we've got, and I'm not going to use perfect scientific notation just so we can think about it a little bit better. We're going to call this 35 times 10 to the 5th, just so we're using the same values we had up here, kind of. Let's use the 4th so that it's actually the same value. 35 times 10 to the 4th, and we're going to divide or have a fraction 5 times 10 to the 1. We don't need that 1, that's repetitive, but we're going to include it here just so we can see what's going on. Now remember, this is the same thing as 35 times 10 to the 4th divided by 5 times 10 to the 1. These are two different ways of writing the same problem. Okay, so let's expand it out again. I've got 35 times 10, 2, 3, and 4. And below, I've got 5 times 10, and I've only got one of them. And we know right away that we can cancel out one of our 10s. So then we're left with, I'll go back to my blue. We're left with 35 divided by 5, and on top 10 to the 1, 2, 3. And so that gives us 35 divided by 5 is 7 times 10 to the 3rd. All right, I'll do one more. Okay. 30 times 10 to the 2nd over 5 times 10 to the 3rd. Actually, I'll do two more because I want you to see one with a negative on the bottom. So if I expand this out, I've got 30 times 10 times 10, 5, 2, 3. And again, I can cancel these ones, and I'm left with 1 on the bottom. So then I have 30 over 5 times 10 to the 1st, and 30 divided by 5 gives me 6, and I know that this is the same as 10 to the negative 1 because it's a division. So 6 times 10 to the negative 1 is how we would put that into scientific notation. And so let's figure out what the rule is. So here I have a division of 30 times 5, and then for my exponents, I just did 2 minus 3 to get negative 1, just like when we talked about our exponent rules. So here, and that's going to be the same on top. I have 35 divided by 5 gave me 7, and 4 minus 1 gave me 3. So my rule is going to be divide the numbers and subtract the exponent for division. And then again, if we run into a situation where that gives us a weird number, like 35 times 10 to the 5th, then we're going to adjust our scientific notation. We're going to simplify so that we only have one number in front of the decimal, one digit. Okay, and then I said I just wanted to give you one so that you can see it where you have a negative exponent on the bottom. So I'm going to use the same one, but I'm going to say this is a negative 3. Ugly. 30 times 10 to the 2nd over 5 times 10 to the negative 3. And I'm going to use the rule this time. I'm going to say, okay, well, 30 divided by 5 gives me 6. And this is going to be times 10 to the 2 minus negative 3 minus a negative is plus. Remember, from your math classes, a minus and negative is a plus. So this is 6 times 10 to the 2 minus negative 3 turns into plus 3, so to the 5th. And then to prove to you that that rule worked, let's expand it out. Again, you don't have to do the expanding it out part. That's just to help you. So now, if you're rusty on your fractions, this part won't be as intuitive for you. But when we're dividing a fraction, that's the same as multiplying on the top. And again, this part, you don't have to do this every time. So if you're like, I don't remember doing this with fractions at all, then just use the rule and you'll be okay. But this is the same as saying nothing. So that would just be 5, which gives me 6 times 10 to the 5th. But again, this part, this is a slightly complicated math rule that you might not remember. Hopefully you do, and if you don't, feel free to review fraction rules. If you haven't taken algebra especially, that might be a little confusing, but you can just use the rule. You can say, okay, I'm going to divide, and then I'm going to subtract my exponents. I just have to remember when I subtract negatives that turns into addition. All right, so I'm going to make a separate video for adding and subtracting with scientific notation because it's a little bit more complicated.